Hi, Algebra 1. We're going to be working on lesson 19 here, and we're going to be focusing on compound and simple interest, looking at which one changes faster. Here we go. In our first problem here, we have a family that has $1,000 to invest, and they're looking at two different options. Bonds that offer 2% simple interest, or a savings account, which charges a $20 fee and then 2% compound interest. Both options pay interest annually. We can see in the table that the bonds are just adding $20 each year. That's because it has a 2% simple interest, which means 2% of $1,000, which is $20, just gets added every year. It doesn't build on itself. So after 3 years, there's going to be $1,060. In the savings account, it's increasing by 2% interest, but it is a compound interest. So that means they are taking the previous amount and multiplying it by 1.02. There's your 2%. And then to get the next year, they take the previous amount and multiply it by 1.02. So we see this growth factor of 1.02 in our compound interest. So now let's write an equation for each of these. We're going to use T for time. We're representing years. And we can see that the bonds are showing a linear pattern because we're just adding the same amount each year. So we need to remember our general form for a linear equation, y equals mx plus b. And our m is going to be 20. That's our slope because that's what's being added on every year. So that'll be times t plus b, which is our y-intercept or our starting point, which would be $1,000. The savings account with compound interest is showing an exponential pattern because we have the same multiplier happening every time. So for years t, we're going to have our starting value, remember a times b to the x power. So our starting value is 980 times our growth factor, 1.02, to the t power. So there's the equation for that one. So label and remember that a simple interest is just going to be a linear pattern, and a compound interest situation is going to be an exponential pattern. So which investment option should the family choose? You can graph both of these equations to get a better sense of what's happening here. Here's our simple interest in purple, and you'll see that it does start out a little bit higher because they didn't charge that $20 fee, but that is just a straight line going on and on forever. Whereas the compound interest is going to be an exponential curve. So we have to start out a little bit less because they charge $20 in interest. But they're about the same at 12 years. And then after that, the exponential will just keep growing faster and faster and faster and faster. So if this family is going to keep the money in there for 12 years or more, then they might as well go with the compound interest because it'll start accumulating a lot more money more quickly. Here I filled out the column for f of x. F of x is just taking 2 times x. So 2 times 1, 2 times 10, 2 times 50, 2 times 100, 2 times 500. Here are the values we got for function g of x, where we plugged in values for x right there. Trying to figure out which function will reach a value of 2,000 first, I plugged in 1,000 for x, and function f gets me 2,000. Function g gets us 20,959. So clearly function g reached 2,000 a long time before x was 1,000. So function g is going to reach 2,000 first.